All right, let's dive into one of React 18's biggest game changers. We're going to talk about a set of tools that make your app feel incredibly responsive, even when it's doing some really heavy lifting in the background.
You know that feeling, right? You've built a UI, maybe a search filter, and the whole thing just hangs. It feels sluggish. You type a few letters and nothing. Then, bam, all the characters show up at once. It's a classic sign of a janky UI, and honestly, it's a terrible user experience.
And this right here is the perfect example. You've got a simple input field, and it's trying to filter a massive list of items. Now, with like a dozen items, no problem. But scale that up to thousands or even tens of thousands, and that simple little feature suddenly becomes a huge performance bottleneck. It's exactly where lag loves to hide.
Okay, so here's our game plan. First, we'll really dig into why UIs get laggy. Then we'll talk about the difference between synchronous and concurrent rendering. We'll get into this idea of urgent versus non-urgent updates, and then we'll get hands-on with the useTransition and useDeferredValue hooks. And finally, we'll wrap it all up with some key takeaways and best practices.
All right, let's jump right in. So, what's at the root of this whole problem? Well, the villain behind all this frustrating lag actually has a name, and it's synchronous rendering.
So here's the deal with synchronous rendering. Once a render starts, absolutely nothing can interrupt it. Think of it like a train on a single track. It has to get to the end of the line before anything else can happen. So if React starts updating that giant list, the whole app is just locked. It won't even process your next keystroke until it's completely done.
And this is where the real problem lies. You have these two different kinds of tasks. There are the fast, urgent parts, like you typing in a search box. That should feel instant. But then you have the slow, non-urgent parts, like filtering a list of 10,000 items. The big issue? The slow part blocks the fast part. It literally holds your keystrokes hostage, and the entire UI just grinds to a halt.
Okay, so that's the problem. Now for the solution, our hero, concurrent rendering. And I want to be super clear here, this isn't just some small new feature in React 18. This is a fundamental, ground-up change in how React actually works. So what does it do? Well, with concurrent rendering, a render can be interrupted. That's the magic word. React can start working on that long, slow list update, but if something more important comes up, like you typing another character, it can actually pause the list render, handle your keystroke immediately to keep the input responsive, and then go back to finishing the other work later. It's a total game changer. So to really tap into this new power, we need a slightly different way of thinking. It's a really powerful mental model where we start separating our updates into two buckets, the urgent stuff and the not so urgent stuff.
And you know, there's a fantastic analogy for this that developers will get right away. Git branching. Think of your current snappy UI as the main branch. When you start that slow list filter, it's like you're starting work on a feature branch in the background. But then, a hot fix, an urgent update comes in, like the user typing another letter. What does React do? It pauses work on the feature render, switches over to handle the hot fix immediately, and then, once that's done, it just goes back to working on the feature branch. It's so clever.
Okay. This all sounds great in theory, right? But how do we actually tell React, hey, this update is urgent, but this one isn't? Well, that brings us to our first real tool, the useTransition hook. It's super simple. When you use this hook, you get back two things. First, a Boolean value is pending, which tells you if a low priority render is still running. And second, a function called startTransition, which is what you'll use to wrap your slow state updates.
And this is really the aha moment. Take a look at this comparison. The before code on the left is the laggy way. Both setSearchTerm and setFiltered are treated as urgent, so everything freezes. But look at the after code. All we do is wrap that slow, heavy filtering logic inside startTransition. That's it. We're telling React, the input text is urgent, but you can take your time with the list. It's that simple.
And remember that isPending variable we got? This is where it's so useful. You can use it to show a loading spinner or some kind of feedback to the user. So while React is busy filtering that big list in the background, isPending is true. The user sees that something is happening, but the key is the UI is still completely responsive. They can keep typing, clicking, whatever. It's a huge win.
Okay, so useTransition is amazing when you're the one calling setState. But what if you don't control the code that's causing the update? Maybe you're getting a value from a parent component or a third-party library. Well, for that scenario, React gives us another tool, the useDeferredValue hook.
What this hook does is let you defer updating a part of the UI. Basically, you're telling React, hey, it's totally cool if this specific value is a little bit stale for a moment.
It returns a version of the value that will intentionally lag behind the real-time state, which lets all the urgent updates render first, preventing any blocking.
So when should you use which one? The key difference is what you wrap. With useTransition, you wrap the state setting action. It's more imperative. With useDeferredValue, you wrap the value itself, which is more declarative. Here's a simple rule of thumb. If you have access to the setState call, useTransition is probably what you want. If you're just working with a value that you don't control the source of, useDeferredValue is your go-to.
All right, now before you get all excited and rush off to wrap everything and start transition, hold on. It's really important to understand a few key rules to make sure you're using these features wisely.
First, a big anti-pattern alert. Do not wrap a controlled input setState call. That just defeats the whole purpose by tying the slow and fast updates back together. Second, remember that React can only pause rendering between components, not in the middle of one giant component's render function. So you still need to break up your slow components. And probably the most important point, these hooks are a last resort. Always try to optimize your code first. Use these for things that are just unavoidably slow. And finally, keep in mind that there are only two tiers, urgent or not urgent. There are no levels in between.
And this really gets to the heart of it all. This isn't magic. It's not actually making your slow code run any faster. The total amount of computation is the same. What it is doing is changing the user's perception of speed by keeping the UI responsive. It won't make your application faster, but it will make it feel faster. And at the end of the day, that's what your users care about.
And that leads me to one last really interesting thought. Right now, all this concurrent magic is still happening on the main thread. But what if it didn't have to? What if these background renders could be pushed off to a completely separate thread using something like web workers? The React team's already looking into this, which could unlock a whole new level of performance. It's an awesome time to be a developer, that's for sure.